From this question, we can easily solve for the sum of the two solutions of given quadratic equation when it has a form of ax squared plus bx plus 3 or plus c equals 0. We can simply take the sum of the two solutions as the negative of b. So here we take the negative of the numerical coefficient of the middle term, which is negative 2a, and the negative of negative 2a is equal to 2a. So we can confidently say that the sum of the two solutions is equal to 2a. Now the question is, how then that could be that the sum is equal to negative b? Let's take, for example, if we're given a quadratic equation in a form of ax squared plus bx plus c is equal to 0, our first attempt is to factor out this quadratic equation by having the product of two binomial. Assuming that we can factor this out by having a product of two binomials by having x plus m times x plus n, which is equal to 0, we can easily say that the solutions of this quadratic equation is, say, x sub 1 is equal to, by taking this factor as equal to 0. So if this is equal to 0, we can say that x plus m is equal to 0 and x is equal to m, rather negative m. And so the one solutions of this quadratic equation is x sub 1 is equal to negative n. And another condition is when we take this another factor is equal to 0, we can say that x plus n is equal to 0 and x is equal to negative n. Another factor or another solution for this quadratic equation is x up to is equal to negative n. Now, the sum of these two solutions, the sum of these two solutions is equal to negative m plus negative n, or simply equal to negative of m plus n. Now, let's go back to this product of two binomial. Considering this x plus m times x plus n is equal to 0 is a factor of this quadratic equation above, we can try to expand this x plus m and x plus n and see what would be the numerical coefficient corresponds to x squared, x, and what is the constant. So let's try to apply the FOIL method. Here we have x times x is x squared plus we have here x times m times x is mx plus n times x is nx plus m times n is equal to 0. Now we're going to combine like terms here. We have here the like terms for the variable x. So we have here x squared plus, let's take out x, and we have m plus n inside the parentheses. We have m plus n times x plus the product of n and m, which is equal to 0. Now we can see that this form is in a form of ax squared plus bx plus c, because m times n is a constant. And here we can say that b is equal to m plus n, therefore. And we can notice that the sum, we'll go back here, the sum of two solutions is equal to the negative of m plus n. If b is equal to m plus n, therefore we can say that sum is equal to negative b. That's why in that kind of question, when we are asked to find the sum of two solutions, we can simply take the negative of the numerical coefficient of the middle term, which is equal to negative b.